How's everyone doing? Your day being good so far? Good talks? I think the lineup was a killer until now. So, we're going to talk about machine learning and AI in the web, and what's happening today, and what are the possibilities. And this talk is only scratching the surface of what is possible. And I hope that you take away home some really good tips and tricks and ways to get started with using AI in the browser. So when we talk about AI in general or machine learning, it's usually done by something like Python. It's been a given for a long time. But we're going to talk about, is it actually true today? Can we do something else with a different language? What TensorFlow came on, there were a lot of fluencies, there were a lot of people jumping in and contributing to all of those machine learning models and creating some awesome stuff that just people could import and use. But they lacked the widespread usage. If you wanted to share a model with someone else, they needed to jump into your machine, or you needed to export it in some way and transfer it somewhere else, and then do a whole bunch of other stuff. So it wasn't really accessible for a lot of people. And the majority of developers who were involved in doing machine learning were back-end developers, sort of. So we're going to go through basically covering this area and how it's been shifted. And the focus is now not only on the back-end, it's mainly on the web. My name is Yaser. I was a senior lead consultant, at Redify. It's been changed now. I'm a lead consultant at Telstra Purple. So we got rebranded. But you can find me at Twitter. I've got also a website here, and I've contributed to dev.to, Medium, other places as well. So go definitely check these out. There are heaps of content around web and front end mainly that I talk about. So I don't have a lot of time. I just jump into the slides. There are not many slides. It's mainly demos, but I have to go through some slides because at the end of the talk, someone's going to say, okay, share your slides. And I was like, okay, here you go. So let's go. Why we should use it in the browser in the first place? So first of all, we have to care about the distribution of something. If we are publishing it somewhere, like a package, we need to know how we can distribute this into other platforms, how we can let other people know or use this particular feature very easy. As with any other packages, the most and convenient way to do that is like importing it somewhere in a different language system. And in this case, it hasn't been really available to do it in that scale. So it's been a bit limited. It needs to be interactive. So previously, when you were working with machine learning and AI, you coded a bunch of stuff in Python or any other languages, and then you run it, and then you get the result. There's not much you can do in terms of interactivity. If you wanted to change something, you needed to change a config file, run it again. Again, change something else, run it again. So it's not really interactive in terms of you being able to play around with config on the fly and then reflect the changes immediately. There are a whole bunch of sensors which you can use in the web. So previously, all your machine learning models, if you were using, for example, something like Google Colab, get a sensor data into that particular model wasn't available. You had to get the sensor data offline, transfer it in some sort of way, and then bring it into the model, feed it, train it. This now is available to do it live. So if you are using your phone, for example, to do something, you can easily use any of the sensors available, feed it into the machine learning model, and just use it. And the most important part is data stays on the client. You don't need to have the data to do something. You don't need to have physical data available. They can just scream it out through a web server somewhere, and it just gets there and it stays there. So it's like a privacy issue going around with the data, which has been used into the models. Now, how many of you have seen this? few people. So this is called TensorFlow Playground. It is basically an interface in front of TensorFlow model that you can go ahead, play with the parameters, and that will reflect the learning process for you and visualize it. Initially, this was introduced, and then a lot of people got really interested into this. And I was like, oh, okay, we can interact with something which is running in the background. That's so cool. So that's how Google team started to think about making that available, making that machine learning experience, the same experience available on the web. And that's when TensorFlow.js was born. No clap? Okay. Yeah, let's get started. That was my initial reaction, by the way. I was literally blown away by what is available. Now, TensorFlow.js, it was released in March 2018. It was a GPU accelerated via WebGL. So it was using the hardware and the client to do the processing and math. And it allowed inference and training a model basically in the browser. So this was really a huge step towards making that available to a whole bunch of front-end developers like me. You can use TensorFlow in 3 different ways. Yes. So you can create a new model with it and just train it. That's the first one. You can bring an existing model and just use it for inference. So if you have a pre-trained model, you can just bring it in and use it for inference and prediction. Or you can transfer learning, which is called a term where you have a pre-trained model, but you wanted to add something else on top of the pre-trained model. So let's say you have an image classification model, which only can detect, for example, 50 images, and now you want to expand that to 100 images. So you can do that using transfer learning. Now, how does it work behind the scenes is it's got 3 layers. The very first one at the top is model, so that's like your JS level. Behind that model is the layered API, which basically is how you create a model. So you have a bunch of layers, and then you lay them out, you create a model with those layers. I'm not going too deep into the technical concepts here, just to let you know how stuff works. And I'm just going through this because I want to show you how it maps to the current existing machine learning models. So you can use that in 2 ways. You can use it in the web using WebGL, or you can use it on a server side using Node. And if you're asking yourself, okay, so why we moved back to the server side, sometimes you have a large collection of data which you want to use, but you don't want to upload that whole thing into the browser. And that's when the Node server really works well, because you can train your model on the server using file system access, which is pretty fast, export the model, bring it into the web, and then use it for inference. That's a really good use case. So the layers which I mentioned previously map to this. So if you have a Keras model, which is like a type of model in machine learning language, it just maps to the layered API. So you can convert a Keras model into the layered API and then use it in TensorFlow.js, or the core API, which is the normal TensorFlow. Now, there are heaps of currently built up models for you to go check it out. This is a repository which is built by TensorFlow team, and it contains a whole bunch of different models which are ready to use. So from body classification, body part classification, to body segmentation, to, I don't know, image classification, human pose detection, and you've probably seen a bunch of tweets and blog posts going around with people just moving in front of the camera and their body parts will be marked, which I'm going to show you shortly. So without going more into the slides, let's jump to the examples. We first start with the browser example, and then we move to the server-side examples. So the first one is body pics. Now I have to, this is the time where I have to put the mic down. Okay, so we are here, and this is, don't worry about this, this is just my layout of getting stuff handy. I don't have that much time. So, see what happens here. Just do, Sorry, not this one. This is just okay. So I've got that. So this is, I just want to show you. You can see that. Fair enough. That's a good call. Just need to duplicate this probably. You can see it now, hopefully. Okay. So if you go to localhost 5000. Okay, so this is me getting the BodyPix model, placing an image in the browser, load the model, and then do a body segment. So I want to make sure that I know where the body is inside that image. So this is just live done in the browser right now. This might look stupid, but I'm going to show you why it matters. Let's come here and do this. Where is it? Okay. So what I showed you earlier, this is literally like a get a starter with TensorFlow. This is my HTML. It's this small, so I've got a bunch of styling just to make sure that it wraps up. I've got two script files here, which I'm using a CDN, and an image file, an image tag, and a canvas. This is just the HTML. So I'm importing the index.js here, and that image was what you saw on the screen. And I just want to show you how little code do you need to get something like that working. And this is my entire JavaScript file. That's it. That's all you need to get started with TensorFlow.js. What are we doing here? We're getting a reference to the image tag. I'm just using the BodyPix, which is loaded through that script file. Load the model, which takes a while because it's using the Google storage to load the model. And then I'm just pass that image object to it and call a function. This function gives me an object, which is like very similar to what you get from image data of the canvas. What I have in here is I'm just calling another function to mask of what it found to be the human in that image. So the placement of the human, it just found it, gave me an object, and I'm just trying to mask that object. What I get here is what I just draw a mask around the same object using that canvas object. That's it. That's all it needs to do it. So you saw how little it requires to get started. That's like very basic stuff. Now, if I do here that, so I want to show you what other cool stuff you can do. So this is just like a very, very basic example. This is where it gets interesting. Obviously, we have to wait because it just takes a bunch of time to load. And you have to give it permission to use your camera, obviously. Or if you're using one of the voice models, you have to use that. So that's what you get. Is it? Why it's not appearing there? Okay, you see that? All right, so this is the same model. This time, instead of using a static image, I'm just using live feed from camera. And you can see it sort of detects the segments in the picture where it thinks there's a human body somewhere. And I might think, okay, where the hell do I use this? So I've got a question for you. How many of you have used Microsoft Teams? A few people. Nice. That wasn't the part of the question. Microsoft Teams have added a feature. So if you're joining a video call and you're working from home and you have a messy closet behind you, you don't want that to be seen in the video call. So what they've done is they've sort of they fade your background for you. and the audience only sees you in the picture. How they've done it is using this. So if I change this to that, you sort of see behind me, it's getting that. So one of the cool uses is like, you can do stuff like this. And it's super cool. Like they've literally used this to fade the background image of you talking to some people in front of the camera. Cool, cool? All right. So what else? Let's come back here. I'll show you this one. OK, so what other usages does this bring to us? So one of the cool projects that Google has done is creditability, which is called. And the purpose of that is to make music accessible for people who don't have hand. How cool is that? If you can't play music with your hand, you can now play it with your nose. That's one of the cool features, like how it's helping to make web more accessible or to make features in the web more accessible to other people. So a lot of cool stuff are happening at Google. Definitely check this link out. That link on the bottom, it just goes to a product suite where they're using AI in the browser to add heaps of cool stuff in there. So where else we can use this particular inference in the browser? So Airbnb is one of the advanced in this area. They're already using TensorFlow.js to do stuff like, if you're uploading an image of your kitchen, if you want to rent your house and you're uploading an image of a kitchen, they will basically identify that as a kitchen, and they will try to identify objects using the object detection model inside that kitchen. So they can tag stuff properly. Or, for example, they can differentiate between a kitchen and a bedroom. Stuff like that. The most interesting scenario that I realized they already have is if you're uploading an avatar into Airbnb, you might have some sensitive information. You might be uploading your driver license photo or your, I don't know, national security card for US people or some other form of ID card, and you're trying to upload that. They're using basically a object detection, which goes through the image, tries to figure out whether this classifies as sensitive information, and it alerts you that, hey, you're trying to upload a sensitive photo as your avatar. Do you really want to do that or not? So how cool is this? So there are other stuff we can do as well, which we're just going to do now. So where am I? Here. OK, I'm going to put the mark down again. So there are heaps of other models available as well, one of which is speech command. Speech command is like a model which detects words when you speak. So it's like a speech recognition, sort of, like captioning. But it can be used for that. Now, I've just gone ahead and played with the demo, the initial demo, and I changed it a bit. So what I'm going to do now is I'm going to speak to the mic, say some commands, which includes up, down, left, and right, and it will just show an emoji. As simple as that. But I'm going to show you a more complicated example of how that will play out. So I'm going to press start. I'm pretty sure that this is not going to work using mic, but I'm trying. We can't see your demo. You don't need to hear me at this point. Oh, you can? Why is it happening again? OK. So I'm going to press start here. Up, left, right, down. Holy crap. What is that? Well, obviously, the last part was a trick. I just had a default statement there. But it works. It works. So what cool stuff you can do with that, with the same model, is this one. So I've gone ahead and basically got a game going on with just a canvas, a bunch of horizontal lines, and you have to escape. You can use actually, you could see it here. So this is a game which is controlled by voice. So this up, 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 and we wait here. So if you hit those green bars, it's going to feel like the game is over. It's going too fast. Down, down. No, we're not going to get it. It's gone. There you go. Game finished. Game over. But you could play around with the gaming. But you see what I mean? Like you could use this, these models. It's just pretty easy to set up. This took me about half an hour to set up. Got a game, customize it, use that model, get the inference, get the commands, and then feed it into the game, and you play the game. So the point is, it's really easy to set up stuff like that. It's really easy. So you can go ahead and be creative and create something awesome with one of these models, which are pre-trained for you. You don't need to have anything. You don't need to know anything. You just read through the docs and see what config options you can pass into one of those, and then basically use that. So this is a really cool project which is using the same technique. It's using an object reconstruction, what they call it. So what you can do, actually, let me show you live. This one is really interesting. It is sure a bit creepy, but what they've done here is that you can type something in here, and they recreate a bird with what you're typing using machine learning. So it's trying to infer what you're typing and then recreate a bird. So let's say I want a red bird with yellow beak. Does that work? I don't know. Does that exist? Does anyone here know that exists? Let's see. By the way, this is not a real bird. This is just made up. I think I broke the model. Come on. Doing something. We'll get back to that later. But while you're at it, so while we're here, we wait for that to come. Don't worry about that. There are heaps of people out in the community who have taken this a step further, and they've created something really creative with these models. And they all dumped everything into this aijs.rocks website, which is created by one of the Microsoft Azure advocates. His name is Asim. And are we there yet? Didn't work out. Anyway, so you can sort of go through these models. So they've used models to do something really cool. And most of those have like the source code in the GitHub, and they link those. So you can have a go and look at what they've done. And what should we do? Let's do, I don't know, do something funny. This one looks good. So this one is cool because you sort of draw, and then it tries to map your drawing into a real object, basically. It can be a, anything. How cool is this? Like, imagine you're doing something for like children or kids in school. Anyway, so definitely check this site out. Let me just go back and see whether this, oh man, this is bad. I have to report this. Let's do the default. Is there a default there? This is a red. red with white wings and a short beak? I don't know. Maybe it does something. Is it actually working? Let's see. So debug the hell out of this thing. Anyway, let's do. Nah, they've messed it up. I have to. I have to complain. The author is a really nice guy, and yeah, all getting contact with him. Anyway, so that was like the browser side of things. Now we come into the server side of things, the Node.js version. What is available today? So there is this Magenta Studio, which is completely a Node server implementation of using TensorFlow.js on Node. And what they've done here is they've created a product suite which can be used as plug-in to one of the existing apps here. And what it allows you to do, for example, is if you are a guitar player, it can let basically the machine learning model to play bass with your guitar or play something else like drum. So it's a really cool set of products. Definitely go check that link out. How much time do we have? We're on track. And the retraining in Node.js is pretty much the same as you do in the browser. It's just a bit different in terms of you need to load the model from file system. So previously you installed the npm, and then you use require or import to import your model, and then you basically called the load. But the default load method loads the model from their GitHub repo, or sometimes from their storage servers. So you have to override that bit. So what you get here is a browser request, which basically can load it from the disk. And what you do is you just give it a path, local path, so you can basically put the model, which is a JSON file representation of your model, in the path, and then you use file to load the model. So you're overriding the load method, and that's all you need to get the training working in the server side. So what I've done here, Minko from Angular team, he's got a game, basically Mortal Kombat, which is rewritten in JavaScript. And what I've done here is that I've gone ahead and retrained his model with basically, like this one, a set of images from YouTube. So I went and downloaded two different, basically, video from YouTube, one kicking and the punching. And I then converted those videos into static images, so every frame is like one image, and then I went through, got rid of all the duplicates, and what I've done is here is I've used an image augmentation algorithm to give it a bit more variety. So for you, because you visually see something, it's like the same. If someone is standing in front of you and is facing left, for you, it's the same person if they're standing in the right direction. But for the machine learning model, they're two different persons. They're not the same object. So I've tried to rotate the image, use different background colors and a bunch of other stuff. And I've basically resized all of those into the same size. And I've used the server to retrain the model. I'm not going through that because it takes a bunch of time. But what you can do here, if I come here and there's a black background here, so hopefully this works. If I just do, oh, sorry, not that. So what I've here, I've got a folder which contains the model, the JSON file, and I'm serving that through an HTTP server, which is fairly easy on port 5000. And then I've got the Minko's game running, which he's already done that for me, thankfully. I didn't have to go ahead and build the whole thing up. But this will give us, and you can still see that, which is fine. So it'll give us the game, and then it uses the webcam to see me, and hopefully if I do that, I'm not kicking, obviously. That's probably my fault. I've gotten the switch case wrong or something. But anyway, so you get the point. Like, there are a lot of stuff you could do using these models. It doesn't need to be boring. It can be creative. Go check out the AR.js website. Go through all of those models. Try to be creative and bring the AI to web. And this is a really bright future. I see endless opportunities to use this particular technology to make the web more accessible, to make it a bit more interesting for other people, especially for developers. You don't have to work in crappy web forms anymore, or you could. But anyway, thank you for coming along. This was a really pleasure to present this topic to you, and probably we have some time for questions, I guess. Yes.
Oh, I just looked right into the light.
Just a quick question about training on Node. Node being single-threaded, if there's an easy way to solve that?
For server-side training?
Yeah.
Yeah, so basically, previously they were using WebGL in the browser, right? With the Node version, there are three options. The third one is coming, but it's not there yet. But you could use CPU. You could also use the graphic card, the GPU, and also TPU. So this gives you a wide variety of options to utilize the resources to train your model on the server side, especially if you have a large data set. Does that make sense?
But you'd still only have one processor doing the training. What if you wanted to parallelize it? Yeah, you wanted to use 1,000 CPUs or something. Was it a really hefty model you're trying to train?
That's handled by the Node version for you. You don't need to do that. They already are doing it behind the scene, yeah. The good thing about it is just you call a train, and then it will utilize your CPU cores or GPU cores for that. So you don't need to write, how can I phrase this? You don't need to write, for example, async await kind of stuff to make that happen in parallel. They're already doing it for you. So what you have in, it gets a bit complex. What you have is what they call a iteration in training. So you have basically, what's the term for it? It's like epochs, basically. If you define 50 epochs for running the training and you chunk your data set into smaller parts, you could basically say, I want this 10 to be run in first core and this second to be run in second core, and so on and so forth. So that will basically drive it for you in terms of how many parallel jobs do you want to have. But this can get tricky because the Node.js version doesn't sense when to stop. So if you go crazy with that, it will basically consume everything and your system will be unresponsive. So you're going to be careful with that bit.
So does this come back to the file system thing?
Yeah.
So you would just run the same script on 1,000 different containers or whatever, so long as they're all pointing to the same file system, then they can sort of do the task.
There you go.
Any more questions?
Anyone like afternoon tea?
All right.
All right, no one's putting their hand up. I'm eating all the